Second thing we want to take a look at in section 2.6 is combining functions to create new functions. And basically, to simplify this, if you have two functions, you can add them together, you could subtract them, you can multiply them, or you can divide them. And doing those actions will create new functions. So for our example here, where we have f of x and g of x given the way they are, we may be asked to find the function f plus g of x. Well, all you have to do is take f of x and add g of x. So f of x is the quantity x minus 5. G of x is the quantity x squared minus 1. So our sum, f plus g of x, would be x squared plus x minus 6 if we combine like terms. So we have created the new function f plus g of x. The domain of that function, of course, would be all real numbers. You may also be asked to define the function f minus g, which is simply going to be f of x subtract g of x. You have to be careful with your signs here, but it's going to be x minus 5 subtract the quantity x squared minus 1. So we're looking at x minus 5 minus x squared plus 1. Careful with your signs. Then I would write that in descending order and get negative x squared, or the opposite of x squared, plus x minus 4. The domain of that function is also all real numbers. If you see something that looks like this, you're asked to multiply function f of x and function g of x together. So f of x is the same as x minus 5, g of x is the same as x squared minus 1. You're multiplying those binomials to get x cubed minus 5x squared minus x plus 5. And that is f times g of x. Domain, all real numbers. Okay, you also may be asked to find a quotient, f divided by g of x. So that's simply going to be function f of x over function g of x. So we're looking at the quantity x minus 5 divided by the quantity x squared minus 1. And if you can reduce your fraction at all, that's fine. This one does not reduce. But this time when we think about domain, we've got a situation where we have a fraction. We do not want the domain of our function to include any value of x that makes x squared minus 1 equal 0. So I'm thinking x squared minus 1 should not be allowed to be equal to 0. And this, I can do this on some scratch paper. I don't need to see this. And the values of x that are going to make that true are negative 1 and positive 1. So the domain would include anything except those two numbers. So negative infinity to negative 1, union, negative 1 to positive 1, union 1 to infinity. Now there is one more example I want to show you where we build new functions from other functions, and So we've got a different f of x and g of x. This time f of x is a square root of x minus 3, and g of x is a square root of x plus 1. Oops, 1, not 0. There we go. Domain for f of x would be any value of x greater than or equal to 3. Okay, so x minus 3 greater than or equal to 0. So x is greater than or equal to 3. That's how I got that domain. The domain for g is -1 to infinity. Same thought process. X plus 1 greater than or equal to 0. So x greater than or equal to -1. Now, when I put these two functions together as the function f plus g, we're simply going to have a square root of x minus 3 plus a square root of x plus 1. And there's not anything we can do to simplify that equation. That's just the way it's got to look. The domain for that function, however, would have to be 3 to infinity. So you've got to consider the domain for the individual functions first, and then take the most restrictive domain. So kind of the way I'm thinking about this, I got -1, -1 and 3. This first domain, 3 to infinity, and the second domain, -1 to infinity. And what I've got to focus in on, what's going to be okay for our function f plus g of x, is going to be this part of it. Because any value of x that's greater than 3, ooh, I should have filled in circles, excuse me, because those are equal to. Alright, anyway, any value of x that's greater than or equal to 3 is also going to be greater than or equal to -1, and it's going to be okay. If you picked a number in here, like maybe x equals 0, you're not going to be able to put x equals 0 into that first part of the equation. It's not going to work. So just, kind of use some common sense and think about the entire function when you're trying to find the domain for a new function that you've written.